The truss that we're looking at here is supported by a roller at A as a pin joint at B. It carries loads there at P to the left. It joins M, J, and E. As a result of those three loads, we want to know the load that's carried by member BE and AC. We're allowed to use the method of sections. My choice here on drawing a free body diagram, what section I'm going to use, is I'm going to pass some cuts like that. Therefore, what I'm going to have left over in terms of my FBD is going to be this. And I think I need to erase this member there, because what I'm going to show in my free body diagram is going to be, of course, the applied loads there, P at M and J and E. I will be exposing this force there of FAC, the load that is carried by member BE, and that cut passes through CD. It also passes through DE. What that cut has produced for us is a free body diagram with four unknowns. Let's see how many unknowns that we can get from those three equations that can be written down from that FBD. I'm going to write x positive to the right and y positive up. I'm going to do a summation of moments about joint E first. Whenever I write down the summation of moments about E, I've got FAC. It will have a moment arm of 60 and with a plus sign. I have a load P moment arm of 4D, which is plus. I have a second load P, which has a moment arm of 8D, which is also a plus. And for equilibrium, that is a 0. From this, we can get the FAC is equal to minus 12 over 6P. So that's equal to minus twice the load there, P. Since that's a negative, and it means that I assumed it was in tension, that means my assumption was wrong. It's really in compression. Now what I will do is sum forces in Y, and I get minus FAC minus FBE. And those are the only two forces acting in Y. So from that, I get that FBE is a minus FAC. So that gives us a positive 2P. And since that's positive, it says, well, my assumption of tension was actually correct. So, in reflecting back on what we did, we needed to know the load that's carried by member AC and member BE. The cut I made appears to be a dangerous one, or at least one with a futile effort here, because it exposes four unknown forces. However, two of those forces, FCD and FDE, are acting along the same line. So I was able to use a moment equation and a force equation in Y to get two equations for the two unknowns that I needed, and that was FAC and FBE. So in this case, we had more unknowns than equations, but it turns out we were able to solve for at least the two that we wanted to know.